Okay, we're going to go over Boyles law, Charles law, and then you will also need your periodic table for this, and on the very back is Dalton's law. On Dalton's law, this is what we did yesterday. You're just adding up all the partial pressures. For Dalton's law, the answers are already there, if you look closely. I just want you to show me how you got that answer. So you do show your work and you can check it with the answer being provided. And all this says at the very top, P1 plus P2 plus P3 plus P4, however many different elements or pressures there are, you just add them up to get P total. Okay, I'm going to flip it back to the front. You do need a periodic table only for this reason. On some of the questions, it's going to ask you to put the pressure in standard pressure or STP pressure. That's 1 ATM for standard pressure. So if it ever asks what's the pressure for standard pressure, it's 1 ATM. Another formula to know is this, the conversion factors. Let me write there. And I'm going to go ahead and write that one, this one, on the piece of paper. So you should do the same. Back to the front. 1 ATM, 760 mmHg equals, because we may have to convert on some of these. Let's start with number 1. The formula is P1V1 equals P2V2. The question says a container holds 500 milliliters of CO2 at 20 degrees and 742 torr. Torr is just another unit for pressure. So if you see torr, that's your pressure unit. Also, in this formula, is there the letter T for temperature? No, we do not need to involve temperature in this, and that's why I crossed my temperature out. What will be the volume? So we're looking for volume if the pressure is increased. So our P1 V1 V2 is what we're looking for, because again it says what will be the volume. Okay, these can be in milliliters, liters, any type of measurement, as long as both the P's are in the same unit of measurement and both the V's are in the same. So for pressure, this couldn't be torr and then this be ATM. If that were the case, you'd have to convert. Okay, so let's just plug it in up here. So our P1 is times our V1, which is 500, equals our P2. And then for my unknown down here for the V2, I just put X. If you want to put V2, because it just keeps you organized, you could put V2. So I plugged in all my values. That's all this is. So I'm just going to type in my calculator, 742 times 500. Okay, it gave me 371,000 and equals 795. To get these separated, to isolate X, because that's what we're solving for, X is really the V2, we need that. We just do the opposite of what it's currently doing to both sides of the equation. So right now, it's being multiplied by 795. I'm going to divide by 795 on both sides to get rid of it. So 371,000 divided by 795 gives me my value of X, which is really V2. The unit is ml. Anybody have any questions on this? You're going to find whatever you're given, then plug it in. Let's go ahead and do number 2 together. Oops. A gas tank holds 2,785 liters at 830. What is the volume of the propane? So volume is what I'm looking for. So this is V1, P1, B2 at standard pressure. And what did I say standard pressure would be? So you go to your periodic table. It says standard temperature and pressure. The temperature would be 0, and for pressure it would be 1 atm. So that is our P2 value. Bless you. Okay, so we see the problem, or the challenge. These pressures are in 2 different units, so we're going to have to convert. And it's asking for the volume of propane at standard pressure, so we're going to convert it to atm. So step 1, convert. Make your T-chart. Can anyone tell me what number is going to go over here? What number were we given? 830. And what are we looking for? An ATM. So at the very least, you should be able to set this up like this. We know what we want. It goes in the top right box. Whatever we're given, we start off with. If this is mmHg, the units have to match in order to get them to cancel when we're all done and left with ATM. This is where we're going to look at the what to put where. So we want 1 ATM. 1 ATM gives us how much mmHg. So we go here. 1 ATM gives you 760 mmHg. And that number would go there. Are we multiplying or dividing? It's top to bottom, so you're going to divide. So 830 divided by 760. So my P1 value, because that's what we're solving, we just had to convert P1, is 1.09 ATMs. So I'm not using this number anymore. I'm going to use that number. And then I'm just going to plug everything into this equation at the very top. P1 is 1.09 times my V1, 2785, equals my P2, 1, times my V2. The first thing I'm going to do is the left side of the problem because I can type that in my calculator. Multiplying those two gave me 3041.5 equals 1 times V2. I'm going to do the opposite of what it's currently doing. Right now it's being multiplied. I'm going to divide by 1. So it's going to give me 304. You could leave it the same or you could round up. Equals V2. And the unit of measurement for V2 is going to be liters, just like it was when it started. So as you continue to do the next few problems on the Boyles law side, if it does give you a temperature or a unit that you do not need for the formula, do not use it. It's kind of just there. It's throwing you off. It's giving you too much information. Okay, let's go to the Charles law side. So with Charles' law, we do use volume divided by temperature. So it's V1 divided by T1, which is the same thing as saying the initial volume and the initial temperature is equal to V2 and T2 divided by T2. So by the final volume and the final temperature. Okay, so number 1. If you don't like putting the line there, you can write divide because it's the same thing. Let's get my values. It says a container holds 50 milliliters of nitrogen at 25 degrees Celsius. For this particular formula, for Charles' law, do we need the temperature? Yes. We'll talk about converting Celsius to Kelvins in just a second. And it has a pressure of, I crossed it out because in this formula we do not need pressure. What will its volume be? Okay, so V2 is what we're trying to figure out. If the temperature increases by 35 degrees. 35 degrees is not T2. Okay, it increased by 35 degrees. That's not the final temperature. To get the final temperature, you take the 35 plus the 25. For this formula particularly, you need it to be in kelvins. And in order to get kelvins, you just add 273. Kelvins is a unit of measurement for temperature. Okay, so I have everything I need and now I'm just going to plug it in. I'm going to zoom out a little bit. So V1 divided by T1 equals V2 divided by T2. The first part where I'm going to start is the left-hand side because I can actually plug the left-hand side into the calculator. By dividing those two, I get 0.1677. Okay, I need to get the V isolated all by itself. I need to do the opposite of what it's currently doing. Right now, these two are dividing, so I'm going to multiply 333 by both sides. So I take 333 times 0.1677. Hold on. Oh, wait. Anybody get anything different? Okay, and this is volume, and it's going to be in milliliters. I'll let you work the rest on your own, but I just want you to look at number 2. I'm going to zoom in. For the final temperature, a sample of oxygen occupies the volume of 160, so that's your V1. At 91 degrees Celsius, you're going to convert that Celsius to kelvins. What will be the volume of oxygen, so V2 is your unknown, when the temperature drops to 0 degrees? So in this case, you don't have to add anything to get the final temperature. It's already giving you T2 as is. Like the final temperature will be 0 degrees. And you will convert that to kelvins, and by doing that, you just add 273 plus 0. So this isn't 0 degrees, it's 273 kelvins. And on the back side, it's pretty self-explanatory. Like I said, the answers are there in bold. Just show me your work. Just turn the worksheet in when you're done.